The mathematical symbol of today is the Levi-Civitas symbol, which is written as a lowercase epsilon with 3 indices I, j and k. This symbol represents exactly 3 numbers. It's either +1, -1 or 0. And we distinguish these 3 cases depending in which order the numbers 1, 2 and 3 occur in the indices here. If it's in the correct order, which means like you would count 1, 2, 3, then we get out +1. On the other hand, if it's backwards, so like you would count for a countdown 3, 2, 1, then we get out -1. In fact, in this counting order I described, also cyclic permutations are allowed. For example, in the first case, the last position could be the 1 if then the first position is 2 and then comes 3. So this counting here goes in a cyclic way. Hence the third possibility here would be 3, 1, 2. This is also counting forwards. On the other hand, another possibility for counting backwards would be 2, 1, 3. Also here you should think in a cyclic way. And finally then the last possibility would be 1, 3, 2. So what you can remember is the cyclic order here gives us a sign for the symbol. And then in all other cases, maybe all the indices here are equal to 1, we get out 0. Okay, that's the whole definition of the Levi-Civitas symbol with 3 indices. There are also generalizations with more indices, but this one is the most important one because we can use it in 3 dimensions. For example, it's helpful when we deal with the cross product of 2 3-dimensional vectors a and b. So the result of this cross product is again a vector with 3 components. So we can ask, what is the ith component of it? And it turns out this can be calculated using the Levi-Civitas symbol. It's the double sum over all possibilities for j and k, and then we take the Levi-Civitas symbol epsilon I, j, k times the jth component of a times the kth component of b. In fact, this is a formula some people use to define the cross product of 2 3-dimensional vectors. Okay, so this is the Levi-Civitas symbol. Thanks for listening.